Let's look at another example of coupling. Imagine we want to build a browser application. So we're going to take a break from this employee example, and in a project, inside this package, we want to add a new class. New Java class browser. This browser class is going to have one method. So public void navigate. We give it a web address, which is a string, and it will navigate to this address. Now, as part of this, first we need to find the IP address of this website. So this browser object has to contact a DNS server to find the IP address of a given website. In this demo, we don't want to get distracted with all this complexity, but we can assume that finding the IP address of a website is more than one line of code. We probably have to write 5 to 10 lines of code. So in this class, we're going to have a separate method for getting the IP address of a website. Now, let me show you a very cool shortcut. I'm not going to manually create a method like this, like public string find IP address. Forget about it. I'm going to show you my favorite shortcut. So we type the method name here, find IP address. What parameter do we need here? This address, which is a string object. So let's pass that here. This method is going to return the IP address as a string. So we store it here. Now, look at this light bulb. Once again, we can activate this using Alt and Enter. Here, IntelliJ is suggesting to create this method for us. So let's go with that. Now, because we stored the returned value in a string object, it's suggesting to use the string class as the return type, but we can change it if this is not what we want. Let's go with that, so we press Enter. Next is confirming the parameter type. Because we passed a string to this method, it realized that string is probably what we're looking for. So press Enter to confirm, and one more time, done. Now here it's returning null. Let's change this to an IP address like 127.0.0.1. It doesn't really matter. Now, before going any further, let's make this method public. We'll get back to this in a minute. Now, we have the IP address. Next, we need to send an HTTP request to get the content of the home page of this website. So we can create another method like send HTTP request. We give it this IP address, and this will return a string, which is some HTML content. In case you're not familiar with HTML, it's a markup language that we use to build web pages. Now, let's quickly create this method. So Alt and Enter, 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 Enter. So it's returning null. Let's change that to some HTML content. Again, it doesn't really matter. Now, before going any further, let's change this to public. So we have the HTML content, and then for this demo, we can simply print it on the terminal. So let's print that here. Beautiful. Now we're going to use this browser class in our main class. So let me temporarily delete all this code. Here we need to create a browser object. Once again, let me show you a very cool shortcut. I'm not going to type browser equals new browser. That's so boring. We're going to do a new browser. Enter. Now here we have our light bulb. So Alt and Enter, introduce local variable. Done. Now here we can change the name of this variable. I'm happy with what IntelliJ is suggesting. So Enter, done. Now we can put the caret on the type and press Alt and Enter one more time. And here we're going to replace the explicit type with var. Okay, our code is cleaner. Now look at the members of this browser object. We have these three methods: find IP address, navigate, and send HTTP request. In this application, our main class doesn't really care about these two methods, find IP address and send HTTP request. These are implementation details. All we want to do in this main class is to navigate to a web address. So these two methods are unnecessary, and they are polluting the interface of this class, just like a remote control with so many buttons. We want to hide this from the outside. So back to our browser class. When IntelliJ created these methods for us, it declared them as private. That was deliberate. So let's change this to private, and this one too. Now back to the main class. Look at the members of this browser object. Now we only have the navigate method. And of course, we have these other methods, but they're inherited automatically. We don't have to worry about them. So now the interface of this object is much simpler. We're going to have less coupling in the future because this main class is not going to accidentally call one of these other methods in this browser class, like send HTTP request or find IP address. If tomorrow we decide to change any of these methods, our main class is not going to get affected. Let me show you. So if I add a new parameter here, Boolean, like cache, because this method is used only internally inside this class, our main class is not affected. We don't see that method here. So with this technique, we're isolating the changes to this browser class. Now we have a compilation error here because we added a new parameter to this method, and where we're calling it, that is inside the navigate method, we need to pass a Boolean value. So this is the only place where we're modifying code. In contrast, if this method was public and some other classes in our application used it, let me show you. So here we're going to call find IP address, pass something here, and then a Boolean. Now tomorrow we go back to our browser class and decide to remove this parameter. Now look at our main class. This class is broken. We need to modify this code. And this is how a bad design will cause so many breaking changes in software. Earlier we talked about this guy here. He hates object-oriented programming because he tried it and he failed. This is one of the reasons he could have failed. He didn't know about the coupling. He didn't know about the impact of changes. He didn't know what is abstraction. All he did was creating classes with fields and methods. That is not object-oriented programming. Because object-oriented programming has a bunch of techniques. It's not just about features like fields and methods. It's a way of thinking. It's a way of building software. So once again, remember the abstraction principle. We want to reduce the complexity by hiding unnecessary details. In this example, finding the IP address is a detail. So we're going to hide that. There you go. Now we have a compilation problem in this class because we removed this parameter. All right, the problem is gone. Now back to our main class. Here, our browser object only has a single method. It's easier to use, and we're going to have less coupling in the future.